Welcome to the podcast, Koala Reading AI. I am your host and the voice behind the text-to-speech model. Get ready for an exciting journey through the world of computer vision. In today's episode, we have fascinating papers to discuss. Let's begin with a brief overview of each one. Paper 1. Relighting Neural Radiance Fields with Shadow and Highlight Hints. The paper presents a new method for free viewpoint relighting using a neural implicit radiance representation that models both local and global light transport at each point and incorporates shadow and highlight hints. Paper 2. Zero-shot edge detection with SCESAME Spectral clustering-based Ensemble for segment anything model estimation. The paper proposes a novel approach to edge detection called SCESAME, which addresses the problem of over-detecting edges and shows promising results compared to recent CNN-based methods. Paper 3. Eventful transformers, leveraging temporal redundancy in vision transformers. The paper introduces eventful transformers, a novel approach for reducing computational costs in video recognition tasks by exploiting temporal redundancy, resulting in 2-4x computational savings while maintaining accuracy by identifying and reprocessing only significantly changed tokens over time. Now that we have an overview of these exciting papers, let's take a deep dive into each one. We'll explore the abstract methodology and key results of each paper. Paper 1. Relighting Neural Radiance Fields with Shadow and Highlight Hints. Abstract. The paper presents a new approach to free viewpoint relighting using a neural implicit radiance representation. The authors model both local and global light transport at each point and incorporate shadow and highlight hints to allow for relighting from a small set of unstructured photographs. The method is evaluated on synthetic and real-world scenes, and the results show that it outperforms existing methods in terms of visual quality and efficiency. Method. The proposed method builds on the recent success of neural radiance fields, NeRFs, for free viewpoint rendering. NeRFs model the radiance field as a continuous function that maps 3D spatial coordinates and viewing directions to radiance values. However, NeRFs suffer from limitations in terms of relighting, as they require a large number of training images with consistent lighting conditions. To address this limitation, the authors propose to enrich the lighting information embedded in handheld captured photographs of the object by illuminating each view from a random point light position. This provides a broader, unstructured sampling of the space of appearance changes of an object, while retaining the convenience of handheld acquisition. Furthermore, to improve the reproduction quality of difficult-to-learn components, shadow and highlight hints are provided to the neural radiance representation. The authors also introduce a new optimization method that optimizes the 3D representation, yielding better temporal stability and thus requiring less photographs for view interpolation, at the cost of slightly blurring the images in the presence of camera calibration errors. Results? The proposed method is evaluated on synthetic and real-world scenes, and the results show that it outperforms existing methods in terms of visual quality and efficiency. Ablation studies are conducted to evaluate the impact of different components of the proposed method, such as the number of basis materials and the use of shadow and highlight hints. The results show that the proposed method achieves higher PSNR, SCESAME, and lower LPIPs compared to the baseline methods. The authors also provide qualitative comparisons between additional synthetic scenes relit for a novel viewpoint and novel lighting direction, not part of the training data, and a rendered reference image. For each example, the average PSNR, SSIM, and LPIPs are computed over a uniform sampling of view and light positions. The results show that the proposed method can generate high-quality relit images with realistic lighting and shading effects. In conclusion, the proposed method presents a promising approach to free viewpoint relighting using a neural implicit radiance representation. The method is efficient and can generate high-quality relit images from a small paper too. Zero-shot edge detection with SCESAME Spectral clustering-based Ensemble for segment anything model estimation. Abstract. Edge detection is a fundamental task in computer vision that has been extensively studied. However, most existing methods require a large amount of labeled data for training, which limits their applicability to new domains. In this paper, we propose a zero-shot edge detection method that can detect edges in new domains without any training data. Our method, called SCESAME, combines multiple edge detectors using a simple yet effective mask-based approach. We evaluate our method on the BSDS 500 dataset and show that it outperforms traditional methods and performs almost as well as recent CNN-based methods. Method. The proposed method, SCESAME, is a zero-shot edge detection method that combines multiple edge detectors using a mask-based approach. The key idea is to use masks to select the most reliable edges from each detector and then combine them to produce the final edge map. The masks are generated using a simple thresholding method that removes low-confidence edges and preserves high-confidence edges. The selected edges are then combined using a weighted sum, where the weights are learned using a linear regression model. The weights are learned on a small set of training images and then applied to new images without any further training. We also propose a new edge detector called AMG that is specifically designed for our method. AMG uses a multi-scale approach to detect edges at different scales and orientations. We evaluate our method on the BSDS 500 dataset and show that it outperforms traditional methods and performs almost as well as recent CNN-based methods. Results. The experimental results show that our method, SCESAME, outperforms traditional methods and performs almost as well as recent CNN-based methods. We evaluate our method on the BSDS 500 dataset and show that it achieves an ODS F measure of 0.773 and an OIS F measure of 0.814, which are among the best results reported in the literature. We also show that our method can detect edges in new domains without any training data. For example, we demonstrate that our method can detect edges in satellite images and medical images, which are two domains where labeled data is scarce. We also show that our method can be used for other tasks, such as object detection and semantic segmentation. Overall, our method is a promising approach to zero-shot edge detection that can be applied to a wide range of domains. Paper 3, Eventful Transformers, Leveraging Temporal Redundancy in Vision Transformers. Method. Our method is based on the idea that not all tokens in a sequence are equally important for the final prediction. We introduce a gating mechanism that learns to identify the most informative tokens in a sequence and only compute the attention scores for those tokens. This gating mechanism is trained in a self-supervised manner using a novel objective function that encourages the model to attend to tokens that are relevant for the final prediction. We call this gating mechanism the Eventful gate, as it identifies the most eventful tokens in a sequence. Results. Our experiments show that eventful transformers can achieve state-of-the-art performance on several video processing tasks while reducing the computational cost by up to 50%. We evaluate our method on two challenging datasets, Epic Kitchens and Kinetics 400. On Epic Kitchens, our method achieves a top 1 accuracy of 47.5%, which is a new state-of-the-art result. On Kinetics 400, our method achieves a top 1 accuracy of 77.5%, which is competitive with the current state-of-the-art methods. We also demonstrate the flexibility of our method by showing that it can be used to adaptively control the compute cost at runtime. We introduce a threshold policy that allows the model to dynamically adjust the number of tokens that are attended to based on the complexity of the input sequence. We show that this policy can reduce the computational cost by up to 70% while maintaining high accuracy. In conclusion, our proposed Eventful Transformers method is a promising approach for reducing the computational cost of transformers for video processing tasks while maintaining high accuracy. It introduces a novel gating mechanism that learns to identify the most informative tokens in a sequence and only compute the attention scores for those tokens. Our experiments demonstrate that our method achieves state-of-the-art performance on several video processing tasks while reducing the computational cost by up to 50%. Thank you for listening to Koala Reading AI. Hope you had fun.